Hello students, so today in this video we will talk about the maximum absolute error. Of course, some of the concept, that means the absolute error, you've learned it last week. Okay, so what is it all about? Let's have some quick review. Absolute error. First of all, absolute error is the difference between the actual value and the measured value. Now, assume that in some measurement we have actual value. Then the absolute error is the difference between these two, the measured value and the actual value. We use the greater value minus the smaller value. For example, when you look at this, let's say we have a dictionary. The weight is the actual value is 885. Let's say, assume we know about the actual value. Then if the measured value is 900, what would be the absolute error? We use the greater value minus the smaller value. That's why in this case it's 15 grams. And also, if we have some measured value, say 880, then the greater value is 885, and then minus this value, we have 5 grams. So this is the absolute error. Okay, then the absolute error can be different. With the smaller absolute error, it is closer to the actual value, then it is more accurate. One more example is this. If we know, assume we know the actual length of a pen is 9.17 cm, then two measurements, which one is more accurate? We need to find the absolute error first. So write down the absolute error in these two cases. Okay, one is 0.03, one is 0.17. And we need to compare these two values. Okay, so 0.03 cm is less than 0.17 cm. So that's why Ben's measurement, actually, the absolute error is smaller. It is more accurate. Okay, we use this word more accurate because the absolute error is smaller. Okay, then this is the example that we've talked about last week. So I just have a very quick review. So we found out the absolute error in two cases, and then we compare these two values to find out which one is more accurate. Okay, so you look at the question part B. It is explain your answer, which means you need to do calculation, you need to do comparison, and then do the conclusion. Okay, now we will talk about the maximum absolute error. This time you have the word maximum. What it means? Look at this example. We have 3 toys and we try to use a ruler. The scale interval is 1 cm to measure the height. Now, then the measured value for A is 4 cm, B is 5 cm, C is 4 cm. So, do we know the actual height of the toys? Actually, we don't. Okay, last time we just assumed we have, but in real life cases, we don't have the actual value because the measurements, okay, the actual values are unknown. So when we don't know it, then what is the largest possible absolute error? Now, for example, if we find that the measured value is 4 cm, so would be the actual value be 3.2 cm? No. 3.3 cm? No, because the measured value will become 3 cm. So no. How about 3.4 cm? No, because in this case, the measured value will be 3 cm. 3.49 cm? No. How about 3.6 cm? Yes, because in this case, if the actual value is 3.6 cm, then we can say that the measured value is 4 cm. This is perfectly fine. Okay, and then 4.8 cm? No, because in this case, the measured value is 5 cm. So this one, no, no. And this one, of course, still no. And 4.4 cm? Yes. But be very careful, not just 3.6 and 4.4 cm. Some other values can be the possible height. Let's say, in this case, it should be greater than or equal to 3.5 cm. So if the actual value is 3.5 cm, it's okay, it's perfectly fine. And if it is just smaller than 4.5 cm, just smaller than 4.5 cm can be 4.499, 4.49999, okay? These are examples. So these values can be the actual value. So what can we say about is that the actual height is greater than or equal to 3.5 cm, but it is in the same time less than 4.5 cm. So you can see this symbol, it means 3.5 cm is less than or equal to actual height. Okay, and actual height is less than 4.5 cm. Then this this statement here, we call it the range. So next time when you see the question is asking you the range, you have to write down, oh, actual height is greater than or equal to some value and less than some value. This is the range. Okay, so and then this value 3.5 cm, in this case we call it lower limit, and 4.5 cm we call it upper limit. Do not write 4.4, okay, because you write 4.4, how about 4.45, how about 4.49? You would forget these value, but this value actually is included in this range. So we have to say that the upper limit is 4.5 cm, but the actual height cannot be 4.5 cm, okay? Because if it is 4.5 cm, then the measured value is 5 cm instead of 4 cm. But it is less than 4.5 cm. This is called the upper limit. So when you look at this graph, say this range here, the green part is the range of the actual value. Okay, the lower limit and upper limit. For the upper limit, we use dotted line because it cannot be equal to 4.5 cm. But for lower limit, we have this line. This line means it can be 3.5 cm. Okay, so this is the range here. And then we can say that the absolute error cannot be greater than 0.5 cm. So this is the maximum absolute error. Okay, 0.5 cm is the maximum absolute error. And we can say that maximum absolute error is half of the scale interval. Okay, it's half of the scale interval of the measuring tool. Okay, so the lower limit just minus the maximum absolute error, but the upper limit use the measure value to add the maximum absolute error. Okay, just like this, 4 cm plus 0.5 cm. 4.5 cm is the upper limit. It is not equal to 4.5 cm, but it is bounded by this value. So this is called upper limit. So on and so on. Let's look at some example. Let's see this measuring tape. Okay, the scale interval is 0.1 cm. Then the maximum absolute error is half of it. So it is 0.05 cm. The other example, let's say you have this mechanical scale. And then the scale interval, you can see this is a 10 gram here. So this is 10 gram. The maximum absolute error is 5 gram because half of it, okay, 5 grams. One more example, how about this one? This is digital caliper. So it's measure the diameter. And we know that this measuring tool is correct to the nearest 0.01 millimeter. Correct to the nearest 0.01 millimeters, it means 0.01 millimeters is the scale interval. So that's why in this case, if I want to find the maximum absolute error, it's just half of this value. So this is 0.005 millimeters is the maximum absolute error. How about this one? This is the thermometer, digital thermometer, correct to 3 significant figures. That means correct to this figure is 0.1 degrees Celsius. If it is correct to the 0.1 degrees Celsius, that means the scale interval is 0.1 degrees Celsius. So the maximum absolute error is half of this value. So this is 0.05 degrees Celsius. So how to find the lower limit and the upper limit of the actual value? Look at this example. Let's say the height is measured as 80 meter and correct to 2 significant figures. That means correct to 1 meter. Right? Find the maximum absolute error first. So maximum absolute error is half of the scale interval. That means in this case it's 0.5 meter. And how to find the range? Remember the range, you have to say the actual height is greater than equal to certain value and less than a value. So you have to write down the lower limit first, 7.5 meter, and the upper limit is this one, 80.5 meter. So the range, we will write it as the actual height is less than 80.5 meter, but it is greater than or equal to 7.5 meter. Remember the symbol used here. Okay? So in daily life, we can find that, so we have some formula. Let's say length times width. So how about it? In this case, we have error in finding length. We have error in finding width. So we will say that finding area, that would be an error. Look at this problem. So let's say we use this ruler. This ruler, the scale interval is 2 cm, okay? So the scale interval is 2 cm. First of all, we need to find the actual length of this square paper first. So the maximum absolute error is half of the scale interval, is 1 cm. So the lower limit, it should be 29 cm, and the upper limit is 31 cm. Okay, this is just the length of the paper. Okay, so the range of the actual length is from 29 cm, but it can be equal to, and then it's less than 31 cm. Very easy in this part. But be very careful for part B. Very careful for part B. Now, for part B, the lower limit of the area is the lower limit of the length times the lower limit of the length. So you get the value is 841 cm squared. And the upper limit is the upper limit of the length times the upper limit of the length. So it is 961. Now you can see, if the measured area, it should be 30 times 30, 900 cm squared. But the differences, okay, here, this one is 61 cm greater than this value, cm squared, greater than 900. But this one is just 59 cm squared, less than 900 cm squared. So you can see the difference here. Okay, the actual error in between these two values. So be very careful of this type of questions. Okay, so some simple follow-up questions. So how about these? What is the maximum absolute error? For the first case, correct to the nearest 100 meter. So that's why the maximum absolute error is 50 meter. For part B, correct to 3 significant figures. That means the scale interval is 10 meter. So half of it is the maximum absolute error. Then you can get this value is 5 meter. Lastly, if Amy takes this 70.0 seconds to complete 400 meter run, so what is the range of the actual time taken? Now, first of all, we need to find is the lower limit. And first of all, find the maximum absolute error is half of the scale interval, 0.25 seconds. Then the lower limit of the actual time you can get is this one. And the upper limit of the actual time you can get is this one. So you have two different values for time. Okay, it's the actual time. So the lower limit and the upper limit. Okay, so this is how to find the range. That's the end of this part.